So the Ethernet, the first step, what we look at when we discuss the Ethernet, the frame, correct? How the frame is going to look like. Now if we're switching, when we switch to the Wi-Fi, do you think the frame it's going to look like? It's going to be the same? So in the Ethernet, what's the frame? We said what's the frame size? Should be minimum 64, correct? And we said there is 46 data and there is 18, correct? Do you think the frame it's gonna look like the same as the wireless? It will look different because it's different technology, all right? So let's go and discuss the Ethernet. Okay, and the wireless. So what is the Wi-Fi name? Now the Ethernet, remember what is the project we mentioned before? What is the main project? IEEE, correct? IEEE. For the Ethernet, what we name it? 802.1. Not dot. Come on, confuse me. That's 3. The Ethernet. For the wireless, it's 802.1. So that's for the wireless. So that's what they call it. And we'll see. All right. So wireless, how you communicate through the wireless in general. I'm not talking about the wireless, maybe Bluetooth, maybe different things. So can we do computer to computer? Can we communicate directly from computer A to computer B through the wireless? Yes. Or what is the common thing we do these days? Do we have one here? Maybe, oh yeah, there is one there. So, or we use the access point. So now all the laptops, you connect through the access point. And the access point is wired where? It's connected to the main network switch, all right? So the access point is wired, correct? And our computers, we communicate through the access point. We call it access point. So first technology or first layout we call the BSS. What's the BSS stand for? Basic service set. Basic service set, which is you communicate through one switch or directly somehow. All right. So we will have the BSS either without access point. If you see this computer, so this computer communicate with this computer somehow, and this with this one, and this one, and at the same time still you can communicate to each other, correct? So we don't have an access point. The second way is the BSS using the access point. So all the devices connect to the access point, and the access point is wired to the main switch or the main circuit. All right. What is the second one? It's the ESS, extended service set. How that's going to look like? Can you guess? Can you guess how it's going to look like? So that's when you have multiple access points and all of them, they communicate. So for example, we have this access point and our computer is accessing this access point. In the other building, there is another access point and they communicate through. So how us will communicate with the other computers there? So I will connect to this access point, the other device connect to access point, and then all this access point communicate together through that wired network. So that's why we say extended service set, because you extend your service is not limited to one area. All right. And again, and this extended, you will have the mobile station, which is our computers, all these computers. That's a mobile station. And what you will have a stationary station, which is the access point. This access point, they are not moving. Access point always in the same location, and it's connected through a wire to our main server. All right. So now in the exam, I will ask you, what is the services provided by the wireless in general, either BSS or ESS. What is the difference between them? Yes, the extended, you know, it's you connect multiple BSS to the main switch or main server. So BSS is kind of a small network. We are communicating it through the access point here. Then there is another BSS in the other another building, and now both together is connected through the main switch. Now we are considered as ESS. Correct? You know, if you look at, if you go anywhere, you will not have one access point because, you know, the distance. You know, this access point, it's gonna give you maybe only for around 100 square feet around you. So that's why you need another access point, and that's why we have some concept called roaming. So for now, for example, when you log into the UB network here in this building, but now when you go to the other building, still you have to reconnect? No, because all of them, they connect together. So that's why when you access the network here, still your credential, and when you switch, when you jump from switch to switch or from access point to access point, still you will have access. So you don't have to connect every time. It's well just roaming by itself. All right. All right. So in the wireless, we are using different method. So just remind me, over the Ethernet, what we used. Yeah, but which algorithm we used to detect the media? Carrier sense, multiple access, and collision detection. Now in the wireless, now the question for you, in the wireless, which media we are using? Which media we are using in the wireless? Air, correct? Now, how we will be able to listen to the air? Can we? So that's mean we cannot do collision detection, correct? So we will use different algorithm. We call it collision avoidance. We try to avoid the collision somehow. How we can avoid that? Can you give me some idea how I can avoid? Remember in the Ethernet, what we did collision detection. So you listen to the media. If there is nothing happening, I will send. The collision, it's reduced. The chance if you have collision, it's reduced, but you cannot eliminate it. But now, if collision happened, you have to detect that and they abort the transmission, correct? So that's why you, but in the air or in the wireless, how we do that? We use something collision avoidance. How we can avoid that? Can we avoid that by sending a signal to everybody in this room? Listen, all of us have a laptops. Can avoid the collision by sending a signal to everybody here. I will send data from my computer to computer B, and everybody listening. All right. And when computer B receive the signal, can they be sending a signal to computer A telling you, go ahead? Can? What about the other devices? Now, if the other device C, see a signal, say, you know, we name it RTS, ready to send, I'm sorry. Yeah, ready to send. And device C saw the signal in the air. What that's mean for computer C? Computer C with the computer C will know somebody is trying to send data, correct? So I'm computer A. Let's give you an example. I'm computer A, and there is a computer B and there is computer C. I'm trying to send data from computer A to computer B. What I will do, I will send a signal to everybody. We call it ready to send. I'll send it to everybody, say, you know, I'm sending data from A to B. All right. Now, everybody will receive this message, correct? What's computer B will do? Send signal back to everybody around me or around B. Say, you know, clear to send. I'm ready. I'm free. Send me data. I'm ready for you. So now computer C heard the message. Heard, you know, oh, A trying to send and B is ready. What that mean? What C has to do? do nothing. I cannot do anything. I have to wait. Media is busy now. There is two trying to send data to each other. So in this case, what you're trying to do, you avoid the collision by telling everybody, I'm sending data and I'm ready to receive. The other one, I say, no, oh, now I cannot do anything. All right. So that's the whole concept. The concept is I have to tell everybody I'm sending or I'm receiving, and everybody has to listen. And when you see something going on, I have to wait. I cannot do anything. Wait for how long? That's the question. I have to wait for a long time? No, because I want to send. I have something to say. I cannot wait forever. So we'll see for how long we have to wait. So how the collision avoidance works from that diagram. Let's think about it together. So I'm computer A. I'm sending data. What I will do? I will send signal. I will wait for a time. All right. I will send a time. Then I will send signal RTS, correct? RTS will go to who? Everybody around me. You know, because even I'm sending to A, to B, C has to know I will send something. So everybody has to know. Then after you send, what you have to do, you put your timer. Why we need a timer? Yeah, so you need a timer for a reason, because I'm waiting, correct? Okay, I'm sending a signal to everybody. I'm waiting for B to send me clear to send. Now B for some reason was down or lost net. It doesn't make sense for me as A wait and wait and wait and wait. So what I will do, I will timer. If B send me a signal within 15 seconds, 10 seconds, millisecond, that's, you can define that later. But if the timer expired, that's mean B, something happened with B. I did not receive anything from B. So what I will do, I will just cancel the transmission, let's give the media for somebody else, because somebody else is waiting to send. So now, if I receive now, then I'm waiting for a clear to send. When I receive it, B send me back a signal say clear to send. That means B is ready and willing to receive the data from me. So what I have to do, I will wait for short time of time period. Then I will start sending. After that, what will happen? After, yeah, then when I finish sending, if it's done, success, and I send acknowledge, correct? If for any reason, the time expired, or time out, what I have to do, again, I will add, B as B+1, because I have to try multiple times. You cannot just control the media for yourself. You have to give the chance for the other devices to send. And again, what is the purpose of the random wait time? Because you don't want to just keep sending in the same time. You will try different. So the short thing here, the short concept, I have to tell everybody around me I'm trying to send data. Then when everybody listen to me, they will know I have to wait, because A trying to send data. However, A will not be able to send data until make sure B is ready, B is available live. When A receive the clear to send signal, then I will start sending. And that's how that's gonna look like. All right, so I'm trying to send it from A to B, correct? Then you will have C and D, and maybe you have other, correct? That's what you have. So I will wait. I'm trying to send. I will wait for a short time of period. We call it distributed interframe space. That's what they call it. Then what I will do, I will send RTS. Where I will send the RTS to who? Just to B? To everybody around me. We see anybody can hear me, I will send it to them. Say I'm sending data. Then what's B will do? All right, send signal to B. Will wait for a short time. What we call it short interframe space. Then what B will do? If B ready, okay, and willing to receive data, I'm not busy with something else, I'm live, I will send a clear to send. So now what's A will do? Wait for a short time of period, which is, we say it's short interframe space. Then after that, what I will do? Send the actual data. When B receive the data, I will wait short time. Then what I will do? Then I say acknowledge to A, I received everything. Goodbye. All right. So the question for you here, if you see this one at this point, what's C and D did? They stopped. They did nothing. Just they wait, and they have to wait for this called nav. This a time, you know, it's agreed on in the wireless, you know, world. Okay, we have to wait this time, the nav, which is called no carrier sensing. So during this time, don't do anything. Don't even listen. Don't try to listen to the media. Okay, you have to wait. After this time, then go ahead and listen again and see if you can take the media and send the signal again. So the nav is very important. Why? Why we need that? To avoid the collision. Now, when C and D see there is already signal, somebody trying to send, okay, I will just wait. I'm not going to send anything. I'm not going to do anything. In this case, you just avoid it. You avoid the collision. I'm not sending anything. I will make sure I will not send anything until A finish. All right. So based on this information, let's look like how the format is going to look like. So remember, we need the source, destination, and we just mentioned the nav, the time. We have to agree, you know, on that. So how that's going to look like? So that's how the frame look like in the wireless mode. The first 2 bytes is the frame control, and we will go over it in details. What is the second byte? 2 bytes. What is the second one? The D. What is the D? That's very important. That's the nav time. So here we tell how much the other station they have to wait. That's why we need the nav. We have to agree on that. So all these wireless devices, they have to know how much nav I have to do or I have to wait. Okay. Then you will have address 1, 2, 3, 4. We will go over them. We'll see what's the difference. Why we need. Remember in the Ethernet, how many addresses we had? In the Ethernet, how many addresses we need? In the frame, when we did build the frame, you need the source and destination. But here, why we need 4? Address 1, 2, 3, 4. We'll see now. We'll see the difference. Okay. Then what you will have here, the sequence number. What is the sequence number? The frame, because remember, when you send a message, you divide it to frames. So you have just to flag which sequence you send, 1, 2, 3, 4. Why we need that? Why you need the frame? Why you want to put sequence for the frame? Because maybe the destination will receive a frame not in the right order. Maybe I will receive a frame 2 before 1. Maybe I'll receive a frame 4 before 1. So in this case, if you know the sequence number, when you receive all of them, what you have to do? Guys, when you receive a frame, you receive, you know, if you're trying to send a frame 1 to 5, and the destination receive frame 5, 3, 4, 2, 1, what you have to do? You have to reorder them. So I have to put them in the right sequence. I have to put sequence 1, 2, 3, 4, 5. Because you know, if you not put them in order, what's going to happen? No collision. When you send 5 frames and you receive them in wrong order. So when you send a frame, let's say you're trying to send 5 frames. No, the right destination. But if you send frame 1, 2, 3, 4, 5, but the destination receives them as 5, 3, 2, 1, what you have to do? You have to reorder them. That's why we need the sequence number. If you know the sequence number, you will be able to order. Even if I receive frame 5 before 3, I will know that's 5. I have to put them in the right order. That's why we need the sequence number. All right. And again, you know, FSC, that's for what they call it, the FSC, error correction. That's for error correction. And the frame, that's the actual data from 0 to 2312 byte. All right. So now let's go about, that's very important. That's the most important frame, because that's the control, tell you what you have to do. All right. So the first 2 bits, it's for the current, for the protocol version, which is 0. Now we are using, you know, version 0. The type, what is the type? Type, if it's 00, it's management. If it's 01, is control. If it's 10, is data. So can you give me an example for a control message? What is the control message? Is the RTC a control message? Ready to receive? RTR is ready to receive. Send, ready to send. RTS, ready to send. Clear to send. Oh, is that control message? Yes. What about the data? Is the actual message. So remember, in the wireless, you're sending data, but you have to sometimes you send RTS and CTS, ready to send and clear to send. Those control, trying to control the communication when I send, when I receive. That's why we will have the type. Okay. So now let's talk about the subtype. So how many bits for the subtype? It's 4 bits, correct? If it's 1011 is RTS. If it's 1100, CTS. If it's 1101, acknowledge. So that's mean when I receive a message or a frame, okay, then I open it and I start looking for the subtype. When I see RTS, when I see what the RTS, it's 1011. When I see the subtype, that you will understand that's not a data, that's a control message. I'm telling, you know, the destination, I want to send you something. All right. So that's a control. That's why you need all this information. That's why when you build, that's how they design it. When you put the frame, I'm trying to tell the destination what I'm trying to send them. Is I'm sending you data now, or just that's a control message? Is that a management message? So the destination has to know when they open the message, they have to know, is that actual data or that just a control message? Is that acknowledgement or is that RTS? Without this field, you will not know what exactly coming to you. So that's why we have to follow the format of the frame. So for example, I'm trying to send RTS. So that's the RTS. What's the RTS you need? I'm trying to send RTS from A to B. So you need the frame control, always you need that. What is the D? The D is the nav. Because, you know, everybody, when you send RTS, I'm sending that to everybody around me. So the other people, they have to know how much the nav, how much I have to wait before I do anything, correct? Then address 1, address 2. Why we need only 2 addresses? Remember the frame, the original frame, we say address 1, 2, 3, 4. Now, why only address 1 and address 2 I need here? Why? Because I'm the source. I'm trying to send a message to B. So is there any need more addresses? No, 2 addresses enough, me and the destination. If the destination B and C received it, do you think C will worry about it? No, because the address is not there. C address is not there, so I don't have to worry about it. I will know from the RTS, from this RTS, I will know A trying to send something to B, and that's what I care about. Okay, in this case, I have to wait for this time, for the D time, the nav time, before I do anything else. All right. What about the acknowledgement? Why we need 1 address in the acknowledgement? Why we need a one address only? Why we need two addresses? Who answered the question, he will get 10 points. Remember, in the RTS, we had two addresses, source and destination, correct? Now in the acknowledgement, why we need one address? Why? Because the acknowledgement, you're not sending that to everybody. You're sending that because you know the source. I'm sending that to A. I'm telling A, I received the message. So you don't have to send the acknowledgement to everybody else. That's what you care about. For RTS, no. RTS, remember, RTS, I have to send it to everybody around me, but I have to tell them A trying to send to B. So then the other station, they will know, okay, that's not part of my, that's not me. So I have to wait. But the acknowledgement, nobody else has to hear it. You send it only to a specific device, because that's why, remember in the main, the original frame will have address 1, 2, 3, 4, because sometimes some of the frame you need the 4 addresses. Sometimes you need only 2 addresses. Sometimes you need only 1 address based on the data you're trying to send. Are you trying to send control message, or you're trying to send a management message, or you're actually trying to send actual data? So that's why the frame is look different. But in the Ethernet, the frame always the same. The Ethernet always the same. Why? Because using wired, not wireless. All right. So for the addresses, remember when we, let me go back here. Remember from the frame control here, you will have this to attribute, to from, okay? To from, based on the value, you will know what you're trying to send to. So if you go back, now to DSS and from DSS. What's mean if it's 0, 0? Okay, another 10 points if somebody give me the correct answer. Why? What is mean when you see 0, 0? When you put 0 to DS and to from DS 0, 0, what that's mean? It's a code, you know. When the device see that as 0, 0, what that's mean? I'm trying to send from a computer to another computer directly. There is nothing involved between them. I'm trying to send it from A to B without even going to the access point. All right. So now what about when I do 0, 1? That's another 10 points. 0, 1, yes. What you said? No. So close enough. Explain it more. Which one? So what is your goal? You're trying to send it from host A to B, correct? But how you will be able to do that if we are connected through an access point? So first you have to send your data to the access point. An access point will send it from the access point to the destination. So your answer is close enough. So when I'm sending from when it's 0, 0, 1, I'm telling everybody now I'm sending from me as computer A to the access point. All right. So now what's gonna happen if it's 1, 0? Now from the access point to host B. All right. So that's the code. So even I'm trying to send to B, still I have to send my data to access point. Then access point change the frame, because again it has to tweak it because we'll have different address, then send it to host B. So what about 1 to 1? Huh? That's the communication happen between two access points. So I'm connected to access point, and this access point connected to another access point. So let's say, computer B is not around me. It's far from here. There is no way for my access point, this one I connected to, reach out to the computer B. So it has to go from access point, then to the access point which B connected to. So that's why, remember, we have 4 addresses in your code. Sometimes you need 1 or 2 or 4 or 3 based on that. And in the frame control, you have to tell, the device I'm sending the data to, I'm telling them what is the path. If we are 2 computers connected to each other, next to each other, so to DS and from DS has to be 0, 0, because that you're telling each other we communicate directly. If I'm sending it through an access point, first my frame is coming from my computer to the access point, has to be 0, 1. Then the access point will rebuild the frame, and then the address will be 1, 0. Now, if there is 2 access point, you have to jump from access point to access point, then it has to be 1, 1. It's a map, it's really the map. The frame, it's a map for how you communicate. That's why they build it. They try to figure out all these issues and add all this field, that frame control with all this field, to make the communication easier and more clear. All right, so let's go next. All right, so there is a few issues with this algorithm, or with the wireless in general. Remember which algorithm we are using in the wireless world? Carrier sense, multiple access, collision, avoidance, correct? But what is the issue? One of the issue is the hidden. What does mean? Can I explain here? So let me explain here. So now let's say, you have computer A and B, A, and C. B can see only A, cannot reach up to C. C is far from B, correct? So now let's assume B trying to send data to A. What's going to happen here? Yeah, so A will send RTS to A, correct? B will send RTS to B. Now, do you think C will know that's B trying to send something to A? No, because it's far, it's hidden. RTS cannot reach to C. So what's going to happen there? So C, there is a chance C will try to send data to A, correct? Then what's going to happen? We'll have a collision. So in this case, what you can do, how you solve this issue? Let's see here. Maybe that's making it clear. So I'm trying to send it from B to A. B will send RTS. Perfect. What's A will do? A, if I'm ready, what I will have to do? I will send clear to send. I will send signal now to everybody. Can C see the RTS CTS? Yes, because it's next to me. Let me do it quick here. Remember, you have A, or let's say B, you have A, then you have C, correct? B trying to send something to A. What you first have to do? Send RTS. All right. So if A is ready, willing to receive, what we'll do? Send CTS, correct? But what else? Remember, A will send it to everybody around me. So that's why you have CTS. So now C, what we'll do, C? We'll know A, it's waiting for data from A. A is waiting data from B. That means I cannot do anything. I cannot send anything. So C has to wait, correct? So that's why it's a hidden issue, but with that what they call RTS and CTS, we solve the hidden issue. All right. What is the second issue? Second issue. The second issue is exposed. So I have A, B, C, and D. All right. I'm trying to send data from A to B. So what I did here, RTS. Perfect. What B will do? Will send CTS and CTS. Okay. Now C wants to send data to D. So what's going to happen there? Unfortunately, C cannot send anything to D. Why? Because the CTS receive the CTS. So you know there's somebody trying to send. Even the communication between C and D will not interfere with A and B because they're not exposed. So D, it's really far from A and B. Still, unfortunately, C will not be able to send data. They have to wait. So you just wasted the bandwidth because of the CT. So this one, there is no solution. You know, they have to wait. That's why they call it what they call it, exposed station problem. Clear? So that's one of the issues. So again, they're trying to send it from A to B. So you send RTS. I'm sorry, you're sending from A to B, sending RTS in both directions, then clear to send. Unfortunately, C will not be able to send. So when you see the diagram, you will know what's the issue there. All right. Okay. Bluetooth. What is the Bluetooth? It's another way to communicate through wireless, correct? It's a wireless signal. All right. What is the Bluetooth? Where we use the Bluetooth? Can we use it for a network? We can use it, you know, for like, you know, for the mouse, for different type of technology. Okay. Can we use a Bluetooth for the LAN? We can. And what is the Bluetooth? So there is two type of Bluetooth, something called Biconet, and the other one is what they call the other one? Yes. So what's the difference? First of all, Bluetooth, you can connect only up to 8 devices. So only 8 devices can communicate through Bluetooth, not more than that. However, there is another 8 waiting. So let's say you have 8, all of them up and running and connected. When one of them goes down, one of the secondary or waiting list can join. All right. So then they communicate. That's the first scenario. Second scenario, when you have 2 Bluetooth network and one of the node is acting as a primary. So that's this one, it's kind of working as primary and secondary. It's connecting the 2 Bluetooth together, 2 Bluetooth network together. So I'm not going to go in details. That's something you can read. All right. And the frame, what is the frame? It's 72-bit for access code and 54 bits for header. And the data from 240 up to 2070-40. You can go over it, how it's look like. Again, each frame, each header has field, and each field means something. It's similar to Ethernet and to the wireless, but different meaning. For example, in the header, there is address a 3-bit. Can you tell me why it's a 3-bit for the address? Can you tell me why it's a 3? Who give me the answer? Here we got another 10 points. What's the reason it's only 3 bits? I just mentioned that. Okay, I'll give you the answer. How many Bluetooth devices you can connect? 8. So how many bits you need to present that? 3 bits. So that's why it's the 3 bits, you know? Okay. What about else? What else we have? Again, I don't want to go on all of them in details. You can go. For example, what is the F? What's mean when if the frame F? I'm sorry. Let me go back. Oh. Okay, what's mean the frame F here? What's mean when it's 1? Simply is telling, you know, the buffer is full. I cannot receive more data. So that's the thing. What's mean if it's A? That's mean, okay, it's the bit 70 or for acknowledgement. Okay, what's mean S? It's a sequence number. All right. So when it's going to tell you what is a sequence number, what is the, if it's acknowledgement. I'm sorry. So the point here, each technology, you need a specific frame to send out. You have data, but you add a header to it. And the header means a lot. It's going to give you the map, how you communicate. What is the size of the frame? You know, the destination and the source address. If it's you're trying to communicate it through the access point or no. All this field is going to help you to understand the communication. All right. I will skip some of these. The modem, you can, who used the modem before? The young generation, I don't think so. You know anything about the modem? Did you use modem before? Did you use it? Through the phone line, correct? Okay, remember when you try to connect, how the sound is going to look like? Trying to dial a number. When you connect to the modem to try to connect to the internet, you will hear the tone trying to connect, something like this, and the speed was awesome. You know, like, you know, too slow. So I'm not gonna. It's obsolete. Nobody using the modem now. Everybody using the cable now these days, correct? And after the modem, what came to the market after the modem? The DSL. Did anybody use DSL? Before the cable, before we have the cable. Again, the DSL, it's meant all for residential. It's not meant for business. Of course, it's providing voice and data. All right. So after the DSL, what is the technology we have now? Cables, correct? Yeah. What is the cable? What cables provide to us? Voice, video, and data. That's why in your home, you can, if you order or you join Spectrum, for example, or Verizon, your modem will give you, if you want, it's a service. You can have a phone line, okay, and you can have internet, and you can have TV channels. So you can 3 of them in one device. It's up to your service. You can select which one, or you can buy all of them. So again, modem is meant only a long time ago for internet, slow internet. They improved that by going to the DSL, which provide voice and data. Then lately, what we have the cable, which provide the 3 things. And even like, let's talk about cables, because that's the existing technology. Cables is divided to 750 channels. Okay, and this channels is divided to small channel for the voice, because it's mostly nobody's using voice these days. Usually you need only one line for home to call and receive calls. Then you will have a huge number of channels for what? For video. Why we need you know, a lot of channels for video? Because that's really the heavy load. That's why you have to give the video, because streaming pictures and videos need a huge bandwidth. That's why we have a big bandwidth for that. Then finally, you have the data, which is the internet. When you don't browse the internet, you need the data bandwidth or the data channels. So if you go, I tried to go over that very quick and we'll end today. So for I think I'm going to the right direction. So hopefully next week we'll have the projector fixed because it's really hard without. All right, so the cable, again, what we will have for the cable, we have data upstream and you will have data downstream, correct? That's for your internet. And you will have the video. Video, it has a, a high bandwidth because you usually consume a lot of bandwidth. That's why we need more channels. Can you tell me what's the difference between data upstream and data downstream? Why the data downstream has more channels than upstream? Can you give me a reasonable answer? Why we need downloading more than uploading? Because when you browse the internet, usually you download the data, right? Uploading that that's usually at the server side. When you have a server trying to upload, okay, you need a bigger bandwidth. But as end user, usually you will have a high bandwidth for downloading because that's the module we browsing, we just downloading stuff. Okay, uploading is the opposite. We don't need that high bandwidth. Now, when you go to a server site or business or company, usually the opposite. They will have a high upload bandwidth and low download bandwidth. All right, so guys, I think that's enough for today. You can finish the chapter. What is remaining? You can skip. I'm not going to ask you anything about. I'm not going to ask you about what they call it. Switch 1, 3, section 3-4. I'm not going to ask you anything about that. And you can just go over it just for your knowledge. And the lately, just I want to explain that very quick. There's a three devices. We have hub, we have a switch, and we have router. Can you tell me what's the difference between the hub, switch, and router? So hub or repeater works on which layer? In the physical layer. And the switch, or they call it two-level switch or two-layer switch, work at the data link layer. Router is work at the network layer. All right. So that's the more. So the hub simply, it's just a repeater. I receive the signal. Hub is a dummy station. I receive a signal and I send it. Everybody. The switch, it's more smarter. The switch, what will do the switch? Will receive the data and I put in the queue and start sending that to the right destination. So I receive the data. I know it's coming from A, has to go to B. I don't have to send it to everybody. Correct? Router is more advanced. Router is give you the quicker path. Which path I have to go? I have to go, if I want to go to New Jersey, which is the best way? I have to go through 95 or I have to go through 15. Then that's the router, how router decide. Okay, is the best time now, best way to New Jersey, go to 95 and go to New York, and from New York, go to Washington Bridge, then to New Jersey, or I have to go through 95, then jump on Tabanza Bridge, then go to New Jersey, or I have to go through the 15, then Tabanza Bridge to New Jersey. So the router will find the best path for you, the best, quicker path to decide. That's the router. Switch, still smart, but not like the router. Router is really, that's the smartest device. You can read it, and if you have a question, you can ask me next week. Oh, I'm going back. All right, so guys, if you don't have a question, you can leave. If you have a question, I'm here if you want to ask me. And for the assignment, I will extend it for next week, okay? Because there is a few things explained today. So all right. Question over Zoom.